Okay, so I went ahead and just closed out the Discord. I'm going to record this
Okay.
so everyone else can view it later. I can't stream it. Wi-Fi's not working. Okay, have you guys decided on any particular concepts you want to talk about?
So can I ask my Venus question
Yeah,
really
go ahead.
quickly?
Yeah.
So
Although
what's
now
up?
I have no internet. I have it up.
Darn.
Um,
Okay.
it's what we were doing yesterday on the Discord, and then is this the one from yesterday? Register with the data we carry. Oh no. Wait, hold on.
Okay.
Sorry. This is another. I have like 6 Venuses. What is this one? 14? 14.
It's so funny. My office hours are the exact opposite as it is in the tutoring center. I always have a bunch of like 220 student EE 220 students coming in and like just constantly asking like all of the homework questions, and I don't mind. It's just the stark opposite to office hours because a lot of the time you guys don't have the specific questions.
Wait, you're not recording right now?
No, I am.
Oh, you are?
Yes.
Yeah, I don't like.
Ooh.
Is this it? Sorry, it's literally the thing I asked you yesterday, but and I need to say this on the recording. Like I feel so stupid because I know we've talked about this, and I write everything
Oh,
down.
that's fine.
And it just doesn't.
Sometimes it just doesn't sink in the first, second, or 23rd time. It takes a
It's
while.
Like I'm an idiot or something.
Nah, it's just
I-
sometimes it's just hard to remember stuff. Keep it in.
It's so bad. Okay, so here it is. Let me paste this into Venus. And you can just like tell me what the register should look like or okay. Okay, so it's yesterday's homework and it was this loop. Okay, so it was like the value one. It's from yesterday's homework. We were storing. Do you want me to bring up the thing?
No, it's fine.
Okay. So we had the loop,
Yeah.
and we were looping 1 through 10, and then we were storing.
Where's your label for 4?
What's my label for 4?
Yeah.
What do you mean?
On line 11, where you have J4, the 4 is supposed to be a label that you're supposed to jump to when you run that jump command. So where's your
Yes.
4 label in your code? That's my question. Just like you have a done label,
Oh,
you
I
need a
think it
4
was
label.
Here. Yeah, I think it was here. Yeah, because once we increment it, we're jumping back, and then we're going to store the next value.
I think it should be actually above
Or is
the
it- it's
branch if
beginning.
equal.
Right.
Yeah, because you want to check that condition again.
Yes.
Because otherwise it's just going to be an infinite loop.
I did have this right when I had it in here the first time. I promise.
No, I believe you.
I was just trying to like quickly copy and paste this. When am I done? Okay, so I think my question is, okay, so we have T0.
Yeah.
And I like to, I was switching it to decimal. So it populates with 10. That's my like I cap. Shifting left. So T gets 0 in this case.
Yeah.
Okay, now here's where it like starts to get a little wonky. So it gets, I send it to 230.
Yeah.
But next, my question is here. Wait a minute. Okay, yes. So here I would expect I'm storing the value of I into T1. Right now I is at 0. I is S1 because we're at our 0th iteration of I. When I I step through that though, T0 is, or sorry, not T0. T1 is still my hex address. It doesn't. I would expect this to turn
Okay,
into
now wait a
0.
minute. Now wait a minute.
Okay.
On this line of code, tell me exactly what this instruction does.
Okay, so I'm writing
Mm-hmm.
S1 into the value of the register T1 offset by 0, so it's T1's
That's a memory
address.
location, right?
Yeah, so that should
Okay,
be 230.
so that's a memory location.
Yes, and this is what I'm not understanding, I think.
Yes.
Yeah.
So T1 is a register.
Okay.
The register, the value inside that register has absolutely nothing to do with the contents of memory.
Of the okay.
So they're separate units of memory, right? So
this
I
is
have some
nothing
mess
to-
over here.
Yeah.
This is memory.
Okay.
And this is my register file, which is just a fancy way of saying a collection of registers.
And that's like these two tabs, right?
Yeah, exactly.
They're completely separate.
They're completely separate.
Okay.
And so what you're doing with that instruction, so it was store word, what was it, S10T1?
Yeah.
Okay, so I'm going to explain to you what this does. So store word means that you're going to take a value that's in one of your registers, and you're going to write that value to somewhere in memory.
The data from the register
Yes.
goes into the memory.
Yes. So the data from here is getting fed into and overwrites some data that's in here.
Right.
Now the quote-unquote address in each of these spots is indicated by each of these. The address of my register, i.e. which register I'm looking at, is given here. This tells me which register I want to look at. This tells me where in memory I want to look at.
Okay.
So these two symbols here basically represent like kind of like a home address. Like you're looking up in a phone book maybe where someone lives. This is where I'm going to look for. I'm going to go look for John's house. John lives at 123 Maple Street. So S1 here is my 123 Maple Street. The value stored there is John.
Okay.
That's the data. Those two are separate things. John and his house are not the same thing.
Okay.
In the same way that the location of my register or the location of my memory is not the same as the data stored inside the register, which is not the same as the data stored inside memory at that particular location.
Okay. So my T1 offset by 0 should be at hex 230.
Okay. So this says you're going to go and find the address in memory,
Okay.
hex 230.
Which is right here.
Yes. And you're going to write to that.
Right.
The thing you're writing is the data stored in S1.
Which is 0 at this point, but the next iteration should be 1.
Correct.
Okay.
So it's correct right now.
Yes. Okay, so can I step through?
Go for it.
One
So it
more?
takes you back to the
Yeah.
top.
Let's go back to the register just to make sure. So now I'm at 4 and it should go to 234.
Yeah.
Okay,
Which it
so
does.
that's cool.
Yeah.
And then my S1 is at 1 now because we're now at I equals 1.
Yep.
So now, would my memory address at 234 equal 1?
Correct. So it does work.
Okay.
So it does work.
This is the missing piece.
Yes.
I thought the register was the memory
No.
location.
No. This and these are two completely separate units of storage. So you have a register file, which is typically located inside of a bigger module called a data path,
Gosh.
which itself is typically located inside of a bigger module called your processor. And this part here is a control unit, which interfaces with it. And there's a whole bunch of details I'm not writing in, like peripherals and whatnot. But then this has external communication with the memory. These two are completely separate locations. They have nothing to do with one another.
I spent 2 hours coming through YouTube, reading the textbook over for like the 5th time, watching the videos again. And it was like, I kept thinking these two were the same, and I'm
No.
like, why is my register not
No,
displaying 1?
they have nothing to do with each other in terms of the data.
Gosh, I feel like I just had this epiphany. Can I take a picture
Yes.
of this?
Move.
Thank you so
Okay. Any questions in regards to this information?
go memory to memory. Also.
Yeah, because your processor's in control of moving stuff, right?
Yeah, so we have to go
So you'd have to
data
go memory
to
into
data.
your processor, then back to them. Yeah,
And that's why
right.
I was wondering, why isn't SW and LW the same if we just invert them? And it's like, no, because one is memory to data and is data to memory.
Yep. Yeah. I mean, basically, store word is sending data in this direction, and load word is sending data in that direction.
This makes so much more sense now. This 20th time it's just been explained now. I think because I can like see what's happening in Venus.
Yes. Yes, that does often help.
It really helped me like visualize where the data is going in which thing. So this is perfect. Okay, that was my main question.
Okay. You guys got any other questions for me? I guess I should write the forward. There's lots of other junk inside the data path that I'm not writing. If you are curious about the internals, you can take a look at the chapter which goes over I think it's 7, which goes over like designing the processor from scratch, where you have a register file and an ALU, and then you have a bunch of multiplexers, and the interface between here and memory and some other stuff, as well as a counter to keep track of which address you're in the program memory, which is called PC, and then as well as the program memory itself. And I feel like I'm missing something else. There's some other things as well that I didn't say.
CPE class goes through.
300, the next one right after this.
Okay, you don't have any questions? So I had a random question.
Okay. Yes.
I was looking because registration is like really soon, and I noticed that 301, the only thing listed is a lab, but I thought there was a corresponding course.
Yeah, there is.
Do they sometimes not teach it? The sequence with the lab? Like, I don't think I can take the lab without the.
No, you need to take it's co-requisite. If you take the class, you can then take the lab later, but I don't think you can take the lab and then the class.
There's no class list.
It's
no
possible they haven't posted it yet.
Okay.
You could. I only know of one professor who does 301. I think he's the only one who does it. His name's Dr. Benke. I don't know if you guys know him.
He's teaching 300. Oh, no.
He teaches 301 and a few other courses. I'm taking 2 of his classes right now. I'm taking 403, which is Advanced Embedded Systems. That's the second part of 301. And then 476, which is Robotics.
So cool. I want to do that.
It's not even built yet. It's not even, mounted.
I'm still super impressed in that. Like, I want to take a course that was. Okay, so maybe they'll just post it later.
It's very possible, yes. Sometimes they just don't have them all posted. Especially since the, what's it called? The registration date is until, the 6th or something? So I'd probably wait until the 5th or something and more classes will be posted. I can't recall. Normally he does them every semester from what I'm aware. That's what I thought, so.
Yeah, it's just the lab right now with Dr. Greg.
Yeah.
Okay, so let's see. Yeah, I don't know if we don't have anything specific. Do we want to just review functions? Did you say the homework has functions, right? If we want to do more.
I was thinking of going over E, maybe?
Sure.
Is that more for you?
All right. Let me take a look at the code and I'll write it
Can you
down.
prompt us to answer the questions?
Yeah, that's fine.
Okay. Because I feel like this is the stuff that.
That's a lot of memory space. 220. Is that the homework that's due on Wednesday?
Should be 14, right? Or is it 13 dash?
I feel like there might be a typo in that question.
Yes, there is. Did you see the Dr. Harris said to
Yeah.
re-download it? She fixed it.
Yeah, because I thought I just downloaded it. Right.
Oh, okay. Because
I think the internet's back now.
how do I want to do this? Let me open it up on here.
Yeah, she said I found a couple of typos in the assignment, so please re-download it.
I'll go ahead and open it up over here, and then I'll start writing some stuff on the board.
Okay,
Assignments. 14. Open it up. Okay. All right, I'm gonna write the code down, and I'm gonna kind of condense it a little bit. And when I say condense, I mean I'm not gonna write it exactly as is. I'm gonna have stuff like shoved together just so I can fit everything on the board.
Are you doing
Yeah, E from part whatever that is, the first one. Yeah. Oh, there's only one. Haha. Okay, yeah. E. So let's see. It longer. Fall. Text 250. And then we have. I think I'll actually go ahead and put those up there. Alien 1, Alien 2. And then we have a bunch of wild. Oops. So we have wild. Text at So I scrunched up a bit of the integer declarations all into the top line, but it means the same thing. I'm just saying that I can use those in my program. It doesn't matter what order I declare them in. All right, so I also have to write down where all my things like my base addresses and my variables are stored. So the last few things are that the base addresses for text 1 and text 2 So the base address for the first array of characters, and just so you guys know, an array of characters in this case is the same thing as a string. So what I would do is I would say not S, T1. T1 is equal to hex 200, which is the base address of text 1. And similarly, T2 is going to hold the base address of the next. Okay. And then we also have a few things of note. So length 1 is equal to S1, length 2 is equal to S2, and then the last one is S3 is the numbers. Okay, and just as a quick side question, have you guys used SLT yet?
Like
Set less than.
less than.
Yeah,
We
set,
did it-
set if less than.
We did it in the ALU. I think we did it in the. No, we have not used this in Risk.
Okay. So here's what I'll do first. I was actually gonna, since I mentioned set less than, I was gonna talk about this set of code here. There's another way to kind of interpret this, which is the following. Okay, do you guys see why this is equivalent to this? Because if not, it's fine. It's a little bit weird to write it like that.
No, I mean, I'm more familiar with how we did it where it was like A minus B is less than 1 or equals negative
Yep.
whatever.
So let's plug in some numbers. Let's say that length 1 is equal to 10 and that length 2 is equal to 5. What do you think is going to happen if I, with these two parameters, run through this? What's going to happen? Is longer going to be 1 or 0, and why? It'll be 1 because length 1 is bigger than length 2, right? When you type if and then something, the expression inside is going to evaluate to either a 0 or a non-zero value. In this case, when we do this comparison, length 1 greater than length 2, it'll either be false or true. So if you think of bools, it's going to be either bool 0 or bool 1. In this case, what does it evaluate to? It evaluates to bool 1, right? However, if we hit this case, what would it have evaluated to if we instead go to the else? Bool 0, yeah. So all I'm doing is I'm assigning that Boolean value to longer. Because if this is 1, then longer is 1. If this is not 1, then longer is not 1, i.e. 0. So literally, if length 1 is greater than length 2, then this evaluates to 1, so longer will be 1. If this is not true, so that means length 2 is greater than or equal to length 1, then this evaluates to false, 0, so longer gets 0. So this and that mean the same thing. Are we cool?
Yes.
Now, I'm just going to reorder it a little bit. So I'm going to write it as length 2 less than length 1. So you
We
can
have
just
to do
flip
it
it.
opposite.
Yeah. And so now, this entire thing can actually be encoded with one instruction, which is nice. That's the set less than instruction, SLT. So what SLT does is it sets the destination register if the second operand is less than the third operand. So basically, the way set less than works is exactly like this. If RS1 is less than RS2, then the destination register is going to be equal to 1, else the destination register is 0.
It's really very handy.
Yeah, so it's pretty nice.
Yeah.
And so what you can do is then you can write that exactly out. You can say
Like this.
set if less than or set less than, and you would say longer, which is in this case S3. And then the two things you're comparing are length 2, which is S2, and you're checking if S2 is less than S1. And so again, what this is going to do is it's going to say, okay, if S2 is less than S1, so that's to say if the first number here is less than that second number, then we're going to set S3 to 1. Otherwise, if this one is greater than or equal to that one, we're going to set this to false. And so this does that entire thing. All right. So are we all right with how we turned this if-else statement into set less than?
Yeah.
Okay. Now, of course, you could do it with branches. You could do it with a branch less than or equal to, and then take the branch or don't take the branch, and then assign the value, and then have a jump for the else case, and then jump to the end and all that. You can absolutely do that. Or you can do it with this one instruction. Okay. So with that in mind, I'm going to erase this part from the board because we don't really care about it anymore. We already translated it to assembly. So that was the fun part, I guess, of the problem. Now we're going to get to the harder part. So I'll start by taking a look at that very first line, and you'll actually notice that we haven't initialized longer or length 1 or length 2 to anything, which is a little bit weird because I think... Oh, yes, I forgot to write it. So we haven't initialized longer to anything because it doesn't matter. We're not using it for calculations. We're just going to store a result in it. So it doesn't matter if we initialize longer. So I'm not gonna in my assembly code. Whereas for length 1 and length 2, it does matter. So I'm going to go ahead and initialize those. In the actual code written in the document, those initializations actually appear after this. So these actually are right here. So I'm going to do the chars first. And then we'll initialize those, because these aren't really that bad. Initializing the register to 0 is probably one of the easier things you guys have done.
Yeah.
This one definitely is looking a little bit harder.
Yeah, we haven't initialized any, like, strings.
Yeah, it feels weird, doesn't it?
Yeah, and, like, do we turn those into ASCII or hexadecimal or something?
Yes. Yeah, you would turn them into hexadecimal formatted ASCII code. Yeah, that's exactly.
Wait, really?
Yeah.
Just
No, that's it. Okay, so what this first line is telling you is that wherever that base address is, you should store that string, which is FALL. So you would take a look at your ASCII table and say, okay, well, what is FALL in ASCII? I don't remember. I'm going to look it up. ASCII table. I know that A starts at like 60 something, or I think A starts at 60 something.
91 if it's... Oh, that's capital.
Yeah, it's capital. I'm looking for lowercase. Oh, yeah. Capital is 65. So I want lowercase. That's 97. Okay. And that's in decimal. So we could actually leave it as that. That doesn't matter. we could, because we're just storing those values. It doesn't matter if the way we represent the value is in decimal or in hex. So I'll just write this. A is equal to 97. So the character A is represented by the 8-bit number, which is the same as 97. And I think
It's 1 and 2.
F is 1 and 2, yeah. And they all just go in succession from there. So I want to also pull out the hexadecimal values. 61. And then L is 108. Okay, so what it's asking us to do is it's asking us to store each of these values at different positions after our base address. So for example, the very first character in our string is F. And then it's followed by A. And then it's followed by L. Followed by another L. And actually we have to also make sure we put the null character. Another one. The null character. But how do you actually encode that? Maybe that's the right way. What ASCII value corresponds to the null character? Do you guys know?
It's 0.
Yeah, it's 0. But all of the memory in the, what's it called? All the memory in Venus is already initialized to 0. So if you were lazy, you could just not do that. But if it was real memory, you wouldn't know if it was initialized to some random value. So you do actually have to do that.
Are we doing this by is this a word?
That's exactly what I was going to talk about. So ASCII values take up 2 hexadecimal digits.
So we can do 2 bytes.
2 hexadecimal digits is 8 bits, right? 4 bits for the first, 4 bits for the second. That, though, that's just 1 byte. Yeah, 1 byte is 8. 8 bits. So we can actually do this byte aligned, so we can do it with store and load bytes. So every address, we can increment our addresses by 1 instead of by 4s. So that's pretty nice. So what we want to do is we want to store at address 200, hex 200. So the memory at that address, we want to store F, which is the same thing as hex 64, or 66, pardon. And then the memory at address 201, we want to store the value of A, which is hex 61. And then at 202, we're going to store L. 203, we're going to store L. And 204, we're going to store the null character, which is just all zeros. And then we're going to do the same thing for text 2, except instead of starting at hex 200, we're starting at hex 220. Same deal, though. Just different letters as well, because we're storing the word winter instead of fall. So we'll need a few of those ones as well. Okay, so does everyone understand what we're trying to do here? Not necessarily the code to do it, but what we're attempting to do, or what our goal is. Okay, and this is actually why I said I thought there was a typo. Not because of the typos you guys were mentioning earlier, but that array, that character array is 50 characters long, right? So theoretically, you could make a 49-letter word, or a 49-letter string followed by the null character. That's 50 characters. But how many addresses is that going to go up? Well, it's going to go up by 50, because that's 50 characters, right?
Mm-hmm.
Well, 50 in hexadecimal is hex 32. Hex 3 by 16, or the 3 by 16, that's going to be 48, plus 2, that's 50. All that's important here is that this number is bigger than 20. And so what I'm getting at is, if that character array, that string, was super long, it would actually jump into the other string.
Mm.
That's why I thought there was a typo, because this address should be beyond hex 32, hex 232. It should be at hex 233 at most, or at least. For this example, it doesn't matter because the words don't extend that long. They're all going to be filled with zeros. But in general, it does matter. So that's why I thought there was a typo here.
So we're going from 200 to 203 is getting fall, and then 220 to 223 is getting, no, 225 is getting winter.
Yeah.
That's
Yep.
what we're doing. Okay, that makes sense. Let's load it up.
Okay, so with that in mind, I'm going to erase a little bit of this. I'll erase this as well. Okay, so the first thing we're going to do is we're going to load f into address hex, what was that, hex 200. There you go. So in order to do that, we're going to need to do a store byte. The reason why is because, why are we doing a store?
Wait, can we back up?
Yes.
Don't we have to first get the address into T1?
Well, T1 already has that address.
Or are we assuming it, so we don't need to be like add I
Actually, that's a good question. Let me see.
T1 0. Are we just doing snippets? Oh, it says put the base
Yeah, it does
address.
actually. Yeah, you're right.
so
Let's do
maybe-
that first. So how would I write that then?
So that would be add I T1, comma, 0, comma, hex 200.
Okay, so that's the first line. Yep. And then Javier, what do you think I'd write for the second line? To initialize T2 to hex 220.
Add I, T2, comma, 0, comma, 220.
Yeah, that's it. Same thing as this line, you just change that to T2, change that to hex 220. So I'm not going to write that all out. That's those two initializations there. That one and that one. And I'll go ahead now say we want to do the characters. Though I will say we're going to be storing something to memory, right? Or rather, we're going to be writing to memory.
Yes.
We're writing data to memory. So how am I going to say I want to write hex 61 to memory? Can I just store that immediate value in memory?
With a SB?
Yeah. Could I be like SB hex 61 0 T1? Would that work?
No, our first parameter doesn't it have to be a register?
It does, yes. That's exactly what I was getting at. So we need a temporary register to just store the character that we're trying to write to memory.
Yeah.
So we would have to, before doing this, we would have to say, I'll use T3 because T3 has not been used yet. So I'm going to say add immediate T3. And I'm going to say it's going to be the register 0 plus hex 60. Well, I'm doing F, so hex 66. So that's like saying T3 holds the character F. What would I do next?
Load the rest in. Or are we just assuming you loaded? Oh, should we not load this in and keep reusing T3? Should we like first write the bit?
Doesn't matter. I mean, we can load something in T4, T5, T6, and then do them all at
Yeah.
once. Or we can reuse T3
Reuse.
and do stores. For the sake of the fact that that could have been a longer number or word, I'd say reuse the register. Because after you write one of its bits, you're not going to need to use that previous value anyways.
Would you do it in a for loop and like have it so you?
I mean, you could, but the value's changing every time, and there's no way to know what it is at every instance of the for loop. So you'd actually just write it
Oh,
out
very
line
true,
by
very
line.
true. Yeah.
If it was all A's,
Yeah. Yeah.
do a for loop. If it was all zeros, do a for loop. If it's that word, you can't really get around it. You just have to bite the bullet.
So it's not like it's moving up in increments. Okay.
So on this line, I'm going to be doing what? What would I write?
So sorry, we said we were gonna
I want
reuse
to. I want to.
T3.
Yeah, we're going to reuse T3. So I need to write it to memory before I can
Yeah.
reuse it. So what do I got to do?
Okay, so I'm probably gonna get the syntax wrong
That's fine.
because I'm not looking at anything, but I think it would be SB.
Yeah.
So we're storing. That goes this way.
Yeah, it goes to memory. We're storing to
Okay.
memory.
So SB T3, comma, and we're storing it into two T1s. Okay, so 0 with parentheses T1.
And
And so
that's
now
it?
T1 would have that data from T3, which is
T1 would not have the data. The memory location
Memory
at
location.
address, whatever the value in T1 is, plus 0.
because T1 is the register.
Yeah. Yep.
Okay. Yes.
So
Makes
the
sense.
address here, that address in memory is going to receive the value hex 66.
And T1 just points to the memory location, right?
Yeah.
It's just kind of like
So it is a pointer.
it is a pointer. Okay.
That's how they do pointers.
Can I ask for the semantics? What does the 0 mean next to T?
So that can be any immediate value within a range. So like you can't go like super big. It's just an offset. So literally, if you were trying to calculate this, like if you were trying to write it maybe like in a different way, you could write this as the memory at location, and then whatever the value of T1 is, so whatever the value of stored inside that register is, plus this offset, which in this case is 0, receives the value of, well, whatever is stored in T3. So here, that just means that whatever your base address is, you can then jump up in increments from it. So, if you're trying to access an array at index 0 versus an array at index 1, you can always start with the same base address and you can just offset it by a little bit. And that's why they actually allow it to be in this format. All right. So now with that in mind, I'm going to do the next line. It'll be the easy one to do. Add immediate T3. I can reuse T3 now because I've already stored that previous value to memory. I'm going to say 0, and I'm going to hold the value hex 61 because I just stored F. Now I'm going to store A. Okay, Javier, what's my next question? What's my next line going to be?
We're writing to memory this time.
That's correct.
Okay, so would we be writing T3?
We would be, yeah. But here's the point. So T3 was originally F.
Okay.
And then we stored F in memory, right? So now memory has its own copy of F.
Okay.
So my T3 doesn't need to have that copy anymore. Because even if I overwrite T3, memory is still going to have its own copy of F.
Okay, so different question. So technically, I could also store in S3 if I want to, or S1 or S2, because they all function the same. We just name it T3, or
The only reason why I used T3 was because for intermediary calculations, the standard practice is to use T registers, temporary registers. You could totally use S3 or S2 or S1. The reason why I haven't used those specifically is because I'm going to be using them for other stuff later. So I'm just kind of keeping all my registers as separate
it's just standard
values.
practice,
Yeah.
okay.
And it makes it easier for you
Right.
because you can think this register is always int 1, or this register is always length 1, this register is always length 2, etc.
So it's going to be SB T3, comma, also 0 T1.
Very close. I want to write to the next spot in my array.
So it'd be
So I would say, if originally, well, T1 stores the base address, hex 200. The next spot, the next byte, is at address 201. So I want to write to address 201. So I can do this by utilizing the fact that we have an offset here. If T1 is at 200, I could just say, put a 1 here. And now I'm storing at address 201. Okay. Since we're dealing with characters, and characters have a size of a byte, our index of the array corresponds to the value of the offset, unlike what you guys have done previously where it's been 4 times the value. Because before, when you were storing integer arrays, integers went up in groups of 4s because it's a whole word, and since it's a whole word, the address jumps up by 4s, so this would have had to have been 4 if we were doing an integer array. Since we're doing a character array, that's 1, and they're the same, and it makes it easier to think about.
So on that same note, and I don't want to derail it, could we have loaded FALL as a word and then used LW and increment by, well, we wouldn't have to increment. Oh, but no, it's a character array, not a string array. So that's why we can't do it?
So if you wanted to, you could load each character into just one register, and you
Yeah.
could put 4 characters in one register and write that.
Right.
Yeah, absolutely. How
and
though?
then do the load word into
Yeah.
the whole 32 bits
Mhm.
of the
You mean the store word, because you're storing it to memory.
story.
Yes. You could totally do that.
But I'm looking, it's a character array. So I think, because if it was a string text one array, we could do that, but it's characters, so we have to do it one at a time.
Well, if it was a string array, it'd be even harder. A character array, you could do it. It's just you can't do the whole thing at once, because it's 50 characters. You can't fit 50 characters in one register. If you're going to try and do that like that, you do it in groups of 4. But then the question becomes, well, how do you load 4 bytes into a register? You know how to load a single byte, but if you try and load a second byte, it's going to overwrite it. It's always writing to that bottommost 8 bits. That's wherever the load byte occurs. But since we did it here with add immediates, I guess what you could do is you could do a load immediate instruction,
Yes, that's what
and you'd load the whole immediate in.
Yeah.
You could absolutely do that.
Okay.
And then you'd store the whole thing.
Okay. Yes, that was what I was thinking. Like LUI, the whole thing. Can we use LI? Like
It's a pseudo instruction, but you can use it in code.
Okay.
In class, I don't know. It depends on what she asks.
Okay. Because that's what I've been using in this, but I should probably start then. So,
So you could totally do that.
okay.
The only issue is that you have to remember about the endianness of whatever your system is. Because the way I'm doing it is I'm storing F at index at 200, A at 201, and L at 202, L at 203.
And this might do backwards.
Might do it backwards.
Yeah,
Yeah, because it could be smaller. So you'd have to load it backwards
Yeah.
if you were going to try and do that, which is kind of hard to think about, which is why I went this approach instead.
Yeah. Okay.
But you could totally do it the other way. You could absolutely do it the other way. There's nothing wrong with that.
Yeah. So right now we are doing 0, 1, 2, 3. That's little. No, that's big.
Well, right now, the byte size we're storing is, well, the size we're storing is a byte. So if we think about it in terms of byte, there is no endianness because your units are in bytes. In words, there's an endianness because there's the small end of the word and the big end of the word. Because for a word, the small end or the big end could be stored at an offset of 0 versus an offset of 3. But for a byte just takes up one address. So there is no little or big end with respect to that one byte.
Yes. Okay. That makes sense. I don't know why I was thinking these were all bytes. That
Yes.
it would be huge.
So,
Okay.
you know, one word has 4 different addresses associated with it. Typically, we just consider the base one, the +0, but there are actually 4. It's broken up into 4. Whereas a byte only has 1 address associated with it, so it can't be little or big endian.
I understand.
All right. So, we would actually just continue doing this for L, for the other L, and then for the null character after L, which is just you load zeros. So hex 0, 0.
Okay, and then when we're loading,
Or sorry,
we need-
store. like sed load store.
Yeah. So we have to store the null though from 204 up to 219.
Theoretically, we would actually go all the way up to 232 because it's 50 characters.
Oh, right. But, I mean, that would override our next
Well, it
text.
wouldn't overwrite the next text because the next text is going to be done afterwards, yeah. So actually it would work.
So should we do a for loop for that and, like, do, like, I equals
You could.
this,
Yeah.
and let's go up 40,
Yeah, you could. I'm not going
60.
to lie. I was going to be lazy and just finish at the null character
Mhm.
because that would also work. But, yeah, if you wanted to. Yeah, so you would write AF, you'd write A, and then you do the same thing again for 2Ls. Again, you would just change 0 to 1, 1 to 2, 2 to 3, and you would change the thing you load depending on what the ASCII value of it is. So those are the two things we're changing with every iteration, these two and these two. So you're going to do one for L, you're going to do one for the other L, and then you're going to do one for the null character, which again is just going to be 0, 0 here. So this is going to be stored at index 0, index 1, index 2, index 3, index 4, and so on. And so after that's done, then you do exactly the same thing, but for text 2. So instead of doing it this way with T1, you do it with T2, because T2 is the base address for that other character array. So again, it'd be identical. You just put T2 here instead, because it's a different base address.
Well, and that's why you said, because Venus is it defaults to 0 in memory. So that's why you were saying we wouldn't have to do the null
Yeah, like
necessarily?
if you look at the data in the memory,
Yeah,
it's all zeros initialized.
Okay.
Your
I see
real
what you're
memory
saying now.
is not going to look like that. So you couldn't get away with that. Like in the real world, you could have leftover values.
Okay, I see. Okay. It's all starting to
Yes. But even if that was the case, actually, if you put a null character, you wouldn't have to write anything to the stuff afterwards. Because remember that a string is defined as ending at the null character. So the size of the string, it's going to know it goes from 0 to 4. And even though it could be longer, we're allowing it to be longer, that's where it ends. And then if you overwrote that string with a different string of bigger value, then yeah, it'd get bigger, but then you'd also still write a null character at the end of that anyways. And for this program, we just want it to be able to detect when we've finished the end of the string. That's what those while loops are for. That just finds the length of your string. Because what it's going to do, it's a little weird to see, but it says while, and then whatever this is true. All that's saying, again, is whatever's inside your parentheses, if it evaluates to 0, it's false. If it evaluates to something that's not 0, it's true. So it's going to keep looping while you read in any non-zero character, i.e. you don't read in the null character. So as long as you're not reading in the null character, you're going to keep looping, keep looping, keep looping, keep looping, and then wait. We just read in the null character. The null character has a value hex 0, 0. That evaluates to logic 0. So it's going to end the while loop and exit the while loop.
Wait, can we review that again?
Yes.
So, because to me, I'm thinking, okay, well, are we defining what our length is first?
Nope. It's initialized to 0, and we're finding it.
We're finding it.
Yeah.
Oh, that's what this is doing. Okay. Yes, yes, yes. So, while text 1, 0. Oh, okay. So yeah, it'll first evaluate text 1 at index 0. It'll see something there. It'll increment the length. Text 1, 1.
So what I'm saying here is that it's going to read in each of the characters, and it's going to read it in hexadecimal. So it's going to read an L, it's going to read an F, which is 66. It's going to read an A, which is 61. It's going to read in L, and L is 60, 60, and then it's going to read in null is 0, 0. So this is after a few iterations. So this is the first loop through the while loop, second, third, fourth, fifth.
So when len1 equals 4, it will put a 0 in there. The while will equal false.
And then it'll stop. Yeah,
Okay.
exactly. So it keeps looping here because the inside is non-zero, which evaluates to Boolean true. So it's going to loop. Same deal here. Inside's non-zero, So you loop. Non-zero loop. Non-zero loop. Oh, this evaluates to logical 0. So we're going to exit my loop. So I'm going to stop here. Or exit. On the first go through, I, or in this case length 1, was equal to 0. And then on the second iteration, it was equal to 1, 2, and 3. And I believe, let me work through this in my head. Starting at 0, it's true, it's going to evaluate it. Yeah. Am I doing that right in my head? It's going to be hex 66, and then you're going to increment it. Okay. Upon entering this while loop, length 1 starts at 0, and then it becomes 1 after you finish the while loop. So I'll write it that way. So it enters the while loop at 1, and it exits at 2. It enters the while loop at 2, and it exits at 3. Here it enters the while loop at 3, and it exits as the number 4. And then when you go back up to the top, now since it's 4, it's going to read in the null character, and you're going to exit. So it remains 4, because you didn't increment it. So yes, it will be 4 at the end. And that is the length of the string fall. So it works. So that's actually what each of those while loops are meant to do. Just calculate the length of your string. And that's what they're both going to do. Okay, so as a recap, you're going to load every single individual character, just like this, into all of your spots. So you're going to have 5 spots, because 4 plus 1, for your fall string. And then you're going to have 7 spots. So the winter word is 6 characters, plus a null character at the end. That's 7. So after those 12 blocks of just initializing, then you're going to initialize length 1 and length 2 to zeros. So again, that's just by doing add I, S1, 0, 0. Add I, S2, 0, 0. And then, after all of that initialization stuff, we would then write this code. All right. Will you guys be all right if I erase the initialization from the board?
Yeah.
Okay.
Oh, that's funny. Right underneath it, Dr. Harris put how to initialize and write everything.
Oh, did she?
Yes.
Really?
It's literally exactly what you wrote, so that's good.
Oh, that's hilarious. Okay. Well,
Yeah.
that actually...
I'm so glad we went through it, though, to, like, talk through why.
Yeah. I mean, now you know why.
Yeah. 'Cause I don't think I would have fully grasped that. Just reading it.
Anyways, so you can just copy-paste that for your homework submission.
No,
So
this was so helpful.
all of that initialization stuff is done, and I'm going to assume that the length 1 and length 2 have been already initialized. Go away. So I'm going to go ahead and write the first while loop, and the second one's going to be identical, so I'll leave that one to you guys. Okay. In order to do this while loop, well, actually, I guess I'll ask, how do you think I should do this while loop?
So, can we do like a BEQ for text? Can we do a BEQ for hex 0x20 equals?
The first thing we'd have to do is we'd have to figure out what this is. That is where? Is this in a register or is that in memory? This value.
That's in memory.
That's in memory.
Yeah.
So we need to grab it from memory first. What instruction do I do to do that?
So we're reading it in from memory, right?
Which is?
So I would do a load
Correct.
byte.
So I would say load byte. And I'll just say T3, because that's what the temporary we were using earlier anyways, so we can just use it again. Okay.
Where we did.
So we don't need T3 anymore, or rather, we already used T3 and we overrode the values anyways. We don't need the value that was in T3, so we can use it again here in IAM.
Mm-hmm.
So I'm loading that into T3. So whatever the data is at that place in memory, I'm going to load that data into T3. What do I write over here, though?
data from text 1, length 1, which is, and we're loading it from memory,
Yeah.
and our memory is in T1, so it would have to be 0 parentheses T1.
So T1 is the base address, and this is the offset.
Yeah.
And that's almost correct.
But that won't work in a loop because won't it always collect hex? Oh no, so do we need to like make a offset counter
Yes.
and an SLLI for every time I loop
Yes,
through?
exactly. Well, you don't have to SLI here because it's
Because
offset
it's
by
one.
ones. Yeah.
Sorry, I'm getting like really excited.
No, that's good. Okay, so basically what we're saying is we can't just do this because remember this is going to be in a loop, and because this is going to be in a loop, the T1 here is always fixed. That's always the base address. So you're always reading from the same spot in memory, but you want to read in consecutive spots. You want to kind of go along the array. So what we need to do is we need to have some other temporary variable here, which holds the base plus whatever the offset is for this particular iteration of the loop. So what I'm going to do is I'm going to move this up a little bit. And I'm going to have another temporary to hold. Let's do it like this. I'm going to have another temporary to hold the offset, and I'm going to initialize it to 0. So I'm going to say, actually, yeah, I'll do it like this. T4, I'm going to add T4 0, and I'll do T1. So what this is doing is it's just copying the base address into T4, because T1 has the base address, right? So I'm just storing the base address in T4 again, basically. And now I can use T4 kind of like as scratch work. I can change T4 and I won't lose whatever my base address was. Because if I changed T1, now my base address would be lost forever. So I'm going to use this to hold the base plus the offset at any given time. So I'm going to initialize it with the base, and every iteration through my while loop, I can just increment it, and that's going to correspond to whichever spot I'm at now. So here's what I'm going to do. While. That's my label. And then I'll say store, or sorry, not store, it's going to be load. Load byte. And I'm going to be loading into T3. And the place that I'm looking is going to be at 0, T4. Because again, on every iteration of the loop, T4 is going to get incremented by 1. And I'll do that increment down here. I'll say T4 add immediate T4 with itself and 1. So it's just going to increment T4. And then below that, I'm going to have a jump back to 1. And I'm also going to put a label after the jump so that, because I'm going to have a branch up here, I can have somewhere to branch if my condition's not met. Okay, so I just loaded the byte that I wanted into T3. What do I do now?
You loaded the byte into T3. So you loaded the data.
Yeah, so I have the byte that I cared about.
Yeah.
So I have in the first one F. I have F here. Now what am I going to do with F now that I have F?
Can you compare it
To
0?
Okay.
Can you do a BEQ?
So I'd say branch if equal, and then I'm comparing 0 to T3. And then I assume you want to jump to the end?
If it's well, so don't we need to do the opposite for like speed's sake or whatever?
Yeah,
it'd be
so
B
let's
and
do-
E.
Let's just, for the moment, leave it like this.
Okay.
And let's just think about exactly what happens. If the thing I read, the byte I read, is 0,
Yeah.
do I stay in the loop or do I leave the loop?
If it's 0, we leave the loop.
So what I'm going to do is, if T3 is 0, then I'm going to
Go
go
to
to done.
done.
So I can leave it just like
Yeah.
this. If this is 0, then I'm gonna go to done.
Yeah. So wait, can I ask a quick question?
Yep.
Are we comparing the zero is your
The zero register, yes.
which has nothing in it?
It has
So
the value 0. It's literally 32 bits tied to ground.
Okay, but we could compare, like, if we wanted to compare it to like the number 2, we'd have to load
That
the number
into a
2
register.
into a register, and then
Yes.
compare that register. But
Correct.
this is a weird case. Okay,
Yes.
got it.
There's actually a pseudo instruction.
Oh.
Branch if equal to 0, and then you can just say T3 and done. And this pseudo instruction corresponds to this actual instruction. All right. So if these two registers are equal, then we're going to jump to done. Well, if T3 is 0, i.e. we just read in the null character, yeah, we do want to exit the loop. If that was not the case, then we enter the internals of the while loop. But inside the while loop, all we do is we just increment the length. So my length,
Oh, we just add I.
S1.
So I would say add I, S1, S1, 1.
So now I've incremented my length, and then that's the entire inside of my while loop. The only extra thing I've done is I've incremented my T4 as well, because I need to increment my T4 in order to update it for this read up here. So I increment length 1, and then I increment the address I'm going to be reading from, and then I jump back to the top. I read from that new next address. I check if I've reached my null character. If I have, I escape. If I have not, then I increment my length. I increment to the next spot in my array, continue. This code is going to be identical to that code. You'll just be changing, S1 to S2 for length 2 and so on, but it's identical. It's the exact same while loop, just with different variables used.
So this set of code can be
Almost completely reused for the second while loop. Again, just changing some of the registers we're using. And then after both of those, remember we had that if statement, else statement, which we replaced with SLT. And then that would be the entire set of code.
I would put a for loop after the while, and like done I equals 0 to 50. That was my first thought for like incrementing the offset, and then stick. But then.
Well, you could do that. It would just mean that. Okay, well, you
I
could
know.
do that, but if you always went to 50, the length would be wrong, right? Because length would just be 50, but that's not the length of the string. The amount of space we've allocated for the string is definitely 50, but the size of the string, the actual length of the characters that we care about, is 4, not 50.
If you put it outside of the while loop, then. or
Yeah, so if you
it
did
would
this-
break out of it.
Well, if you did this, and then now down here you had a for loop that went from wherever you were at currently to the other 50 and initialized all those to, yeah, you could do that. There's no reason to, though.
Yeah. No, it wasn't. Oh man, this was great.
Okay. Any questions on this before I end the office
Sorry
hours?
we went over.
No, that's fine.